In this video, we're going to look at another visual representation of probability, and that is a tree diagram. And tree diagrams are helpful in answering a lot of different questions, especially ones where if you had to compute them out by hand using just strict rules of probability, then it would be very, very confusing. This tree diagram actually makes answering the questions a lot easier. So like the Venn diagram, once we have our tree diagram set up, then all these questions below are actually quite easy, at least most of them. So it says if a certain student studies for a test, he has a 92% chance of passing his final. If he does not study, he has only a 45% chance of passing. Based on his schedule in the next week, he predicts there is a 65% chance that he will study. So the key thing to note about the way this problem is stated is that his ability or his probability of passing his final depends on whether or not he studies. And so that's going to explain the sort of branching nature of this diagram here. So what do we know from the beginning? I mean, he either is going to study or he's not going to study. So this is what our tree diagram will start off looking like. So he's going to either study or he's not going to study. And so we know the probability of him studying based on that last sentence. It's that there's a 65% chance. So I'm going to use the decimal equivalent of 65.65. And all that means is that there is a 0.35 or a 35% chance that he won't study, right? Because he's either going to study or he's not, and those probabilities have to sum up to 1. So there's a 35% chance he won't study. So I'm going to label this branch here 0.35. Now from here, it branches off again, because if he studies, he'll either pass or he will not. So he's going to either pass or he will not. So let's just use P for pass, and then not pass. And if he studies, this says that there is a 92% chance he will pass. And if he doesn't study, well, what that means is, if since we're still in the study branch, if he studies, the probability of him passing is 0.92, which means that if he studies, the probability of him not passing at that point is 0.08, because the 92% and that 8% would have to sum up to 1 there. He could also not study, and according to the info, if he does not study, then his chances of passing are only 45%. And it's implied, of course, then that his chances of not passing at that stage would be 0.55%. I'm sorry, 55%. 0.55 is a decimal. And so now what we have is every possible situation that can occur. So this first branch here, the one that goes study to pass, if we multiply those probabilities, that will give us the probability of him studying and passing. So if you do 0.65 times 0.92, you get 0.598. And if you do the next branch, studying and not passing, that's 0.65 times 0.08. That's 0.052. The third branch would be him not studying and passing, so that's 0.35 times 0.45, which is 0.1575. And then the final branch is 0.35 times 0.55, which is 0.1925, and that's the probability of him not studying and not passing. And one thing you might notice, or maybe not at a glance, but if you check, and what should happen is that if you add up all these white values, you'll get 1, because those are all the things that can happen. He's either going to study, pass, study, not pass, or not study, pass, not study, not pass. So those will all sum up to 1. Okay, so now the probabilities are actually really easy, and if it helps you, you might want to go out, to let you make it a little bit more clear. If you want, you can just say, this tree is studies and passes. So studies, and passes. Right, this would be studies and fails. I guess not passes. We can just say fails, I suppose. And this would be not study and passes. And this would be not studies and fails. So now most of these problems are actually really, really easy. So the following determine the following probabilities: that he studies and he passes the test. Well, studies and passes the test is 0.598. Easy enough. That he doesn't study and he doesn't pass the test, that would be the bottom branch here, right? Not study, not pass, 0.1925. Now look at this, the next question, that he passes the test. Well, he can pass the test in 2 scenarios. One is that he studies and passes, and one is that he doesn't study and passes. So if he studies and passes, that is a 0.598 probability, and if he doesn't study and passes, that's 0.1925 probability. So we have to add up those 2 probabilities, because that will give the total probability of him passing considering both scenarios. Adding those together gives you oops, he's passing. I circled the wrong thing. Right? Him passing would not be that one. Sorry about that. I really wanted this one. So that's 0.1575. So those are the ways you can pass. You add those up, you get 0.7555 probability of him passing. Look at question D. That he passes the test given he studies. So this is, I put this in here. It's a very easy problem to compute, but I want to show you how conditional probability, which the word given should alert you to that, how that looks in a tree diagram. Given he studies, so we know he studies. That means we start our analysis right here at the node of him studying. So he studies. From there, the probability that he passes is just 0.92. It's also stated in the problem. So it really is that easy. You just you start at that node and go off from there. No need to multiply, because we know that he studies, so we start there. E is a tricky problem because we want to know the probability that he studies given that he passes the test. So now that we're given that he passes the test, it's a little bit more confusing because passing the test kind of comes later in terms of the nodes here. So unfortunately, or fortunately, depending on your point of view, we've got to use the conditional probability formula, which says that the probability of him studying given that he passed is going to be the probability of him studying and passing divided by the probability of him passing. So we've seen this formula a couple times. This is one situation in which the tree diagram kind of doesn't help directly, but we can get these answers by using the formula. So the probability of him studying and passing is 0.598 divided by the probability of him passing. Well, we actually computed that over here. That was in part C. So that's divided by 0.7555. And when you divide that, you get 0.79915. So that's kind of a sneak attack way of getting that answer, even though the tree diagram doesn't give it directly. So just note the difference between D and E, how easy D was and how E required a little bit more of a process.